So welcome back to everybody. I hope you had a chance to make some new connections and get recaffeinated for the next session. This morning, Secretary Perry shared an exciting vision of the role of advanced manufacturing in the 21st century. And I think the following panel did a very good job describing opportunities that some of the emerging technologies are going to present to the manufacturing sector. But with those opportunities, there's always challenges that we have to discuss. And our next speaker is going to talk about some of those challenges. So it's now my privilege to welcome Mark Menezes, Undersecretary of Energy, to discuss supply chain and cybersecurity challenges for advanced manufacturing. Mr. Menezes serves as the department's principal advisory on energy policy and on a wide array of existing and emerging energy technologies. He is responsible for driving transformative energy policy and technology solutions through coordinated planning, management, and performance of the department's energy programs. Please join me in welcoming Mark Menezes. Thank you.
Well, thank you, Michelle, for that kind introduction. And I'm glad to see that you all are making the most of the technology showcase outside and that you're able to make connections. As the Secretary had said earlier, it's all about making connections and opportunities, but also, you know, we've transformed the department, we hope, in ways that increase the collaboration. I know when Secretary DeBar had brought up this concept of these X labs, you know, it's part of the way where we are trying to bring the labs and what they do to the people, because we think all the labs have a great story to tell. Their states typically know, but it's not as though the whole United States knows what the lab. Oak Ridge has a national following, but part of the X lab goal is to do what you see here today. It is to bring the lab expertise, to bring industry, to bring policymakers, to bring universities, the DOE folks together, so that not only can we collaborate, make connections, et cetera, but we can also become ambassadors and spokespeople too for the great national treasures that these labs are. This is our third X lab, and by all measures, each of them have been a big success. So we hope to continue this, but we do appreciate your participation. And I'd like to echo the Secretary's thanks to Connor and our Office of OTT. Of course, Dr. Thomas Zachariah and everybody at Oak Ridge who, you know, put this together. We really appreciate that. Of course, our energy leadership team, Johnny Moore, and others who have helped, you know, do the logistics and pull this together. And of course, each of you who have taken the time out on your very busy and productive lives to come here and to join and to participate in something that we call X-Lab. We hope that you find it exciting, informative, and again, as the Secretary said, we hope that you're making connections and building and creating opportunities. So today, we have the tremendous opportunity before us to engage and work together for an incredible future. You've heard Secretary Perry's passion, I think, this morning of the technological breakthroughs and, of course, the challenges that we have today. You heard from Assistant Secretary Dan Simmons about how, you know, we're describing the new era in American energy and the new renaissance in American manufacturing. And we're all very, very excited about these prospects. And yet, as we create and as we build, we must protect. And that's going to be the focus of my remarks here this morning. For all of our energy abundance, we see real challenges in energy delivery. And as we modernize our grid, as we make it more flexible, as we make it smarter, as we make it more energy efficient, we must recognize that some very significant challenges are occurring on our sophisticated systems today by cybersecurity. As Secretary Perry has said, he has no higher priority than protecting our energy infrastructure against the threat of cyber attacks. Congress designated the department as the sector-specific agency to protect the energy industry from cyber attacks. It designated the department. We work with the Department of Homeland Security and our other sister agencies, but we have the statutory obligation to ensure that our growing sophisticated energy system is protected from the cyber threats and that it's resilient, because we know that the cyber threats are growing in sophistication and in number. And we know that our energy system has been targeted. We further know that we have no less than 4 nation states who are putting significant resources together for the specific purpose to infiltrate, gain information, and perhaps even do worse things on our energy system. So it's these growing threats that are requiring us, mandating that we think differently and that we respond proactively to ensure that we can provide to the American people a resilient, a reliable, and a secure grid. And that's why, under Secretary Perry, we established a new office at the department. It's called the Office of Cybersecurity, Energy Security, and Emergency Response, which goes by the acronym of CSER. CSER is led by Assistant Secretary Karen Evans and is focused on analyzing, on understanding the sophisticated and evolving threats to our grid, and then on acting and working with our national labs as well as our partners in the public and private sectors to develop the tools and technologies we need to mitigate and to overcome these evolving threats. Now, this office leads our department's efforts to secure our nation's energy infrastructure against all hazards, reduce the risks of and impacts from cyber and other disruptive events, and assist with the restoration activities. CSER's priorities are aligned with the Trump administration's national cyber strategy. It's complemented by our own multi-year plan for energy sector cybersecurity with the following objectives. We need to strengthen our energy sector cybersecurity preparedness. We need to accelerate the research, development, and demonstration of resilient energy delivery systems. And we need to coordinate cyber incident response and recovery by working closely with our local, state, federal agency partners as well as our industry partners. Well, what does that have to do with manufacturing? Well, as we know, to develop a sustainable future, all countries are looking at ways to improve efficiencies, to reduce emissions, to lower cost, and to increase opportunities for all of its citizens. Any mention of, say, the New Green Deal or a reduced carbon future typically assumes this fact, that at a future date, whether it's 2035 or 2050, we will reduce today's electricity demand by electrifying most of our industries, including manufacturing. It is presumed that we will improve the manufacturing processes through electrification, which, because electricity is so much more efficient than the internal combustion engine and other types of energy sources, that we will reduce demand significantly, which will allow us to achieve goals of a sustainable future and lower emissions. It's a goal of all of ours. But to do that, we will, by using the electricity and tying it to the grid, the manufacturing process itself, which is very much a sophisticated operation, it will also become more and more dependent of a safe and reliable grid. So we'll all be related. And based on the report by the National Defense Industry Association, already 35% of all cyber attacks in 2016 were against manufacturers. An estimated 400 companies were targeted in cyber attacks every single day back in 2016, which then resulted in $3 billion worth of losses. There are all kinds of motives behind these attacks, but we know that all of them are very costly. The risks to manufacturers specifically are growing and becoming more sophisticated, so manufacturers must reckon with malicious attempts to corrupt data, steal intellectual property, sabotage industrial equipment, and disable communications. There are several reasons why manufacturers are at special risk. More than most sectors, modern manufacturing relies on flows of materials, parts, assemblies, energy, data, and people from diverse and changing sources. Modern supply chains are hyper-connected systems of contractors and customers. Most factory floors run 24 hours a day and include complex combinations of cutting-edge equipment and decades-old machines, making it difficult to test and maintain systems or rely on existing cybersecurity products and tools. One of the greatest challenges to address manufacturers' cybersecurity is the difficulty in safely testing manufacturing systems. Many security issues arise from the interfaces of interoperable components, often sourced from different manufacturers. Whereas the National Highway Traffic Safety Administration and the National Security Test Site have end-to-end facilities for testing the crashworthiness of vehicles and the survivability of systems, respectively, there is no analog for cybersecurity in manufacturing. Fully 86% of cyber attacks in manufacturing are targeted. Almost half involve theft of intellectual property to gain competitive advantage. Well, were it the case that it were only espionage to steal secrets to gain a competitive advantage? Today, there are malign activities that are taken for all kinds of reasons. I mean, you can pick up any spy novel and read how we have allowed certain nations to get a hold of certain technology, but it's in the manufacturing process that we put some defect in it that 10 years later will take an action and ultimately bring down Putin. But you can read about it, but indeed, it's based on informed thought and experience. Effective response to cyber attacks on manufacturing firms requires a critical assessment of gaps in technology, broad adoption of existing best practices, and research to develop inherently safe systems and rapid response tools. Cybersecurity measures must then be enhanced to protect a highly integrated and interoperable network of manufacturers and service providers. Now, beyond this, differences between disruptions caused by an actual cyber attack and a simple manufacturing defect are difficult to detect. I was just talking to the HP representative, and we were talking about the amount of data that you have available. And indeed, it may be apparent that systems are working fine, and indeed all the systems and preventions that you have in place. It very well could be that with artificial intelligence and machine learning, and with now the availability of great data, you can use these tools to identify anomalies. You may not know what's causing the anomaly. It could be a function of a breakdown in the system. It could be something much worse. But at least now we are developing the tools to be able to take advantage of the data that we have to be able to begin to identify anomalous conditions in our system, whereas in the past, it would have just been in the unknowable realm. Adversaries could gain access to the control system of a manufacturing process and impact product quality without the manufacturer knowing, costing the manufacturer time, energy, and material, or damaged equipment. Cyber physical security must address multiple factories in the supply chain, along with the movement of inputs and outputs that introduce risk, uncertainty, and control challenges. The ideal solution is a network of test bed and cyber range facilities that share information and findings specifically designed for the manufacturing's cybersecurity needs. Manufacturing interoperates with key supporting infrastructure that includes, as I mentioned before, energy grids, but also, remember, water resources, gas, fuel networks, a myriad of transportation and distribution systems. In this context, infrastructure and service providers such as utilities, gas and fuel systems, waste treatment facilities are all part of the manufacturing supply. And as I mentioned, we hope now through the use of AI, through the machine learning, the use of the big data that we're accomplishing here, we can help to identify these threats, anomalies across all of our integrated systems. And just the sheer growth of digital devices and the systems deployed throughout the manufacturing and our electric grid has already created a large deficit in the number of workers with the necessary cybersecurity systems expertise. The potential number of weakest link cyber attack vulnerabilities include constantly evolving technology, the gaps in organization and workforce skills, the growing numbers of common payment system interfaces, and the increasingly numerous and sophisticated cyber attacks themselves. New trends in automated manufacturing, computerization, and networked and tightly integrated supply chains, as well as the emergence of the Internet of Things, introduce new vulnerabilities that will be increasingly difficult to manage unless sufficient investments are made soon. Last fall, auto executives who participate in our Department of Energy's U.S. Drive partnership voiced concern that damage from cyber threats could devastate their production lines. I mean, this is something that keeps them up at night. It's not just shutting them down, but introducing malicious software that reduce the vehicle performance or quality and go unnoticed until the vehicle is in the customer's hands. I mean, this is chilling just to think about it. These challenges within a given company and across multiple companies in a supply chain requires extraordinarily complex solutions. Simply retrofitting existing supply chain management applications won't work. A new approach is needed that begins with the simplest problems and that draws on reusable rather than generative data application design and engineering. Now, I believe the federal government can play a vital role in supporting and coordinating testing infrastructures that span multiple stakeholders. By improving cybersecurity protection, risks can be reduced and can lead to the adoption of more energy efficiency technologies in manufacturing. That's where we want to go. more cyber-secure, energy-efficient manufacturing processes will lead to a more competitive U.S. manufacturing sector, and as we have seen, it will lead the U.S. to continue to lead the nation in lead the world in actual reductions. The Clean Energy Manufacturing Innovation Institute that Secretary Perry mentioned in his remarks this morning, among other DOE initiatives, will help identify solutions to alert and mitigate cybersecurity threats in the types of automated manufacturing systems that enable greater energy productivity and manufacturing. The Institute's efforts should provide significant impacts in developing technology that will improve energy efficiency and cybersecurity of U.S. manufacturing. In the end, we expect it will contribute to a reduction of 10% or more in a supply chain network activities energy use realized through cybersecurity technologies developed under this funding opportunity. So that's a brief overview of our perceived challenges from our perspective. The Department of Energy is an important partner with the U.S. manufacturing industry to help protect our vital infrastructure against inevitable cyber attacks. We are here to help you chart a course forward toward a safer future and a more efficient and more resilient and more technologically advanced energy grid, toward a new American renaissance in advanced manufacturing, and, as Secretary Perry said this morning, a new era in American energy. Let's go there together. Thank you very much for having me here this morning, and thank you for being here.